first question we're gonna look at is a probability question, because quantum mechanics is heavily involved. Quantum mechanics is heavily involved in probabilities. So the first question we're gonna look at is a probability question. Imagine a room with 14 people whose ages are as follows: one person aged 14, one person aged 15, 3 people aged 16, 2 people aged 22, 2 people aged 24, and 5 people aged 25. So let's lay things down. Let's suppose for the moment that n of j is the number of people in the room. The number of people in the room with j age. So j is the age. So if I say n of 14, this will be 1. N of 15, this will be also 1, so forth. N of 17, that has to be 0. N of 25, that's 5. So the sum of all the n's, so the sum of all the n of j's when j starts from 0 all the way to infinity, this must be equal to n, which is in this example 14, number of people in the room. So question number 1. If you select one individual at random from this group, what is the probability what is the probability that this person will be at age 15? That this person will be at age 15. Well, that's pretty simple, right? How many people we have at age 15? One person. How many people in the room? 14. So there's gonna be 1 out of 14, right? So this question here, mathematically, we're gonna write it as P of 15. So P for probability. The probability that we're gonna get to age 15 is 1 out of 14. So P of 25, this should be equal to what? 5 out of 14, right? Notice that these are fractions, okay? So if we're gonna go P of 17, this has to be 0, because we don't have anybody at age 17. Same thing goes with the... So the formula for the P, so P of J is the number of people in that age divided by the total number of people in the room. Very, very important formula, that if you sum all the probabilities, so if you sum all the probabilities from 0 to infinity, you should get 100%. You should get 1. We call this normalization. It's very important. It's gonna show up in a lot of problems. I'm gonna refer to it as normalization, which means I sum all the probabilities together, I should get 1. Alright, question number 2. This should be very simple. What is the most probable age? Well, that's pretty stupid. Most probable age is 25 because we have 5 people 25, right? Of course. I just want you to get the routine of it, okay? So, question number 3. What is the average? What is the average age of the group? What is the average? AVE, I'm gonna refer to it as average. What is the average age of the group? Well, the average, we're gonna take the number of people that has age 14, plus which we have 1 person, plus the number of people with age 15, and that's also 1, plus number of people at age 16, that's 3 times 16, plus 2 times 22, plus 2 times 24, plus 5 times 25, divided by the number of people in the room, that's 14. So doing the math, we get 294 divided by 14. The average age is 21. Notice that nobody in that group has the age of 21, but the average is. Alright, mathematically, the average age, so remember age is J, the average, we're gonna give it the notation, these sideways triangles, okay? So I may refer to it as the average of G, or the expectation value of J. So yeah, so if I call it if I say the expectation value of J, you should think the average of J. Alright, question number what is it, 4? What is the average of the squares of the ages? What is the average of the squares of the ages? So this is the same as saying square the age, which is J, and take the average of it. So what is the average of the square? This is different from the square of the average. Alright? In order to do this, we have to first find a formula for this guy. As you notice from the previous slide, that the expectation value of J is the number of people at a certain age, right, times that age divided by the total number in the room, and we are summing over that age. So this is the expectation value of J. So the number of people at that age times that age divided by total number of people in the room, and we are taking the sum of these two, right? So if that's J, the square of that, we're just gonna have to square this piece here. So J squared expectation value should be the sum of n of J times J squared divided by n. Moving forward, look very carefully at this piece here, n of j divided by n, what is that? This is the probability of that edge, right? This is p of j. So this is the same as let me erase this guy. So expectation value of j squared, this is equal to the sum when j starts from 0 to infinity times j squared times p of j, right? And we're gonna have to do the sum. We don't have the 0, we don't have the 1, we don't have the 2, we don't have the 3, but we have the 4, I mean the 14. So we have 14 squared times the probability of that, which is 1 over 14, then plus 15 squared times the probability of that, which is 1 over 15, plus 16 squared times the probability of that, which is 3 over 14, plus 22 squared times 2 over 14, plus 24 squared 2 over 14, plus 25 squared 5 over 14. Oops. 5 over 14. So okay, I'm not gonna add it up, but you get the idea. So if I ask you what is the expectation value of j squared when j is equal to 22, you just go 22 squared 2 over 14, right? Alright, so we're gonna look at now at something called the standard deviation. This is something that's gonna show up later on in later lectures. We're gonna look at delta j. Delta j is given by j minus the expectation value of j, or the average, and so this is delta j, right? The standard deviation, which we're gonna give it a sigma symbol, sigma squared, is defined. We're gonna define it as delta j squared, and we're gonna take the expectation value of that. Okay, so if we define the sigma square like that, let's prove it, right? Alright, so we have sigma squared. Let's try to go through this fast. Delta j squared, expectation value. So this is going to be equal to the sum of delta j squared times p of j, right? Which is equal to the sum of j minus expectation value of j squared p of j, and this is equal to, let's take this, let's square this piece here. So we have the sum of j squared minus 2j times expectation value of j plus expectation value of j squared times p of j, right? And we have 1, 2, 3 pieces, so this probability of j is for each piece, right? So if we separate all of these, we should get the following, right? P of j plus 2 times expectation value of j times the sum of j, P of j, plus expectation value of j squared times the sum of the probabilities. What is this piece here? The first one. This is the expectation value of the square of the j's, right? The second piece is 2 times expectation value of j times this piece here, which is the expectation value of j. So we have another one, right? Plus expectation value of j squared times the sum of over all the probabilities, which is, we know it's 1, right? So finally sigma square is equal to expectation value of the square of the edges minus j expectation value square, because we have two of them, right? We have this one here and this one, so we have -1 of these. So this is sigma square